Okay, hi guys. What I want to do with you today is just show you how to balance some equations that include polyatomic ions. The other day, last week, we were looking at counting and trying to be able to tell how many of each part we had, and they included those 6 polyatomic ions that I had given you. So if we were looking at K2CO3 in an equation and we were trying to balance and we were, making our little table, we have a K, and then all of a sudden we have 2 capital letters, so that's a polyatomic ion. That's the CO3 ion. All right, so how many K do we have? We have 2 because there's a subscript 2, and CO3 is not in a parentheses. We don't have 3 CO3s. We actually have 3 O's, but if we're looking at CO3 as a polyatomic ion, let's put an imaginary parenthesis around it, I only have one of them. Okay, so we have to remember that when we're doing our balancing of equations, we have to keep that in mind with the polyatomic ions. If I look at NaNO3 and I wanted to do my list, Na, and then I've got NO3. So that's going to be together as a polyatomic ion. For our balancing, we are not going to break apart the polyatomic ions. So they'll stay together. If I have NO3 on this side, then it's going to be exactly NO3 on the other side as well. All right, so if I'm asking you to tally these up, Na subscript is 1, so there's 1 Na. Now NO3, there's not 3 of them because we're looking outside. There's no number there, so we assume that to be 1. If I put a subscript in, not a subscript, I'm sorry, if I put a coefficient in front because of balancing, let's say here's my line and I'm trying to balance, then I've got 3 times 1, 3Na. And remember, it's not going to be 3 times 3 because that 3 is inside the parentheses. The number on the outside of my imaginary parentheses is 1. So 3 times 1, so that's 3NO3. Okay, all right, so let's look at a couple equations and see how we can walk ourselves through these. All right, so let's start with the first one. I couldn't fit them all across in a straight line, so I have the reactants first. Here's my arrow. Here's my products, but I'll just split them just like I did before, and now I'm going to write my list. I'm going to start at the beginning. I have Na, so I'm going to write Na, and then I go over here. I have Al, and in parentheses I have NO3. That's because NO3, polyatomic ion, shows up more than once in this formula. And how do I know? Well, I see parentheses and I see a number on the outside. And that number on the outside tells me how many of them I have. All right, but let's just finish our table first. So this is NO3. Now here's my arrow. So now I'm at the products. So I'm going to recopy in the same order because that just makes it easier. Okay, so go back to the beginning. Na, no subscript, no coefficient, so that's 1. And I go to Al, no subscript, so that's 1. Then I go to NO3. Here's NO3. I'm only looking outside at this number here, this 3 on the outside. So I've got 3 NO3s. Okay, then I go Na, here's Na, so I have 1. Okay, Al, here's Al over here, no subscript, so that's 1. And NO3. Now here's NO3. I don't have 3 of them. Remember up here I had 3, but that's because it was in a parenthesis and the 3 was on the outside. So if I take my marker and I put an imaginary parenthesis around it, okay, there's my NO3 on the inside, what number do I imagine to be on the outside? And that would be 1. So I've got 1 NO3. Okay, so we have 1, 1, 1, 1, 3, 1. So here is where it's not balanced. So I've got to go to this NO3, which is here, and I've got to make it 3. The only place you can put a number is on the line in the front. So the subscript is 1, so what times 1 is 3? And that's 3. So that would be a 3. So then I go down here, I change that to a 3, but remember this also affects the Na. So now 3 times 1, that gives me 3 Nas as well. All right, but that changes my Nas. Now they're not balanced. So I go back up to this one. There's no subscript, so I know that it's 1. What times 1 is 3, and that would be a 3. So 3 times 1, this one changes to a 3. And now I've got 3, 1, 3. So now it's balanced. You can put the 1s on these lines if you want to. You don't have to, but now it's balanced. Okay? Okay, let's look at another one. So here we have some polys in parentheses and some not. So let's draw our line. Let's make our table or list our elements. So I'm going to start with Na. So Na, that 2 is not part of the formula for Na. That just tells me how many I have. Then, just past the Na, I have a capital S, capital O. So that is a polyatomic ion, and I can put imaginary parentheses around it, okay? And I don't have 4 of them, I have 1 of them. But let's just write it out as SO4, and we'll go back and we'll count. Okay, then I go here, I have Ca, and now I have NO3, and NO3 is in a parenthesis. That's my other polyatomic ion. So now I'm going to rewrite this in the same order here. So Na, SO4, Ca, and NO3. Okay, now I'm going to start counting. So I have Na here. I've got a subscript 2, so that means there's 2 of them. Now, SO4, remember we put those imaginary parentheses around it, okay? I don't have 4 SO4, I actually have 1 SO4, so that would be 1. Then I go to Ca, here's Ca here. Ca has a subscript of 1, so that means I have 1. Now, NO3 is in parentheses with a number 2 on the outside. That number 2 tells me how many NO3s I have, so I've got 2. Okay, now I'm going to go to this side, and I'm going to look at the products. Na, here's Na, no subscript, so it's 1. Then I go to SO4. SO4 is over here. I don't have 4 of them because see how this SO4, that 4 is part of this formula. So again, if you need to, you can draw imaginary parentheses around them. And when you do that, it helps you to see that it's all together. And it should also show you that you only have 1 because that 4 is on the inside. There's no number on the outside, so that means 1. Ca is here, no number, so that means 1. Now NO3. NO3 is not in a parenthesis either. So I'm hoping that you see that that's a 1. But let's draw our imaginary parentheses around it. And what number would be on the outside of that imaginary parenthesis would be 1. And there we go. Okay. So right away I can see I'm not balanced here. I have a 2 and a 1. So I'm going to make this one a 2 over here. So I'm going to go up here, and subscript is 1. So what times 1 gives me 2? So the only thing I can put on the line is a 2, because that's the only place I can put it. That's my coefficient. But by putting that 2 there, it also changes the NO3. Remember, the subscript on the outside of the imaginary parentheses is 1. So 2 times 1, that gives me 2 of these NO3s. Okay, so now my NAs are good, my SO4s are good, my CAs are good. Oh, that's good. That's it. That's all we needed there. And again, you can put the 1s in or not. It doesn't matter. You can leave them blank or you can put them in. Some people just need to see them. Okay, so now that one's correct too. All right, let's look at another one. Okay, so this one, here we have some parentheses and some not parentheses. Okay, so first thing I'm going to do is I'm going to draw my line and separate my reactants from my products. I'm going to start up here. I have Ca, so Ca. Then I have NO3 in a parenthesis, so I know that's a polyatomic ion. Then I'm going to go over here. I have K. Now it's not K3, it's K because that's the formula for K. 3 just tells me how many I have. Then after the K, I have a capital P, capital O. I'm hoping that you're starting to recognize that these are polyatomic ions because I only gave you 6 and I'm only going to use the same 6. Okay, so how many PO4s do I have here? I don't have 4, I have 1. Okay, but that doesn't matter yet because we're just listing. I'm going to recopy this on this side, same order, just to make it easy. It's easier to keep track of that way. And then PO4. Okay, now I can start counting. So I start at the beginning. The beginning is Ca, okay, and no subscript, so that means it's 1. And then I have NO3. And there's a subscript 2 on the outside of the parentheses, so that tells me I've got 2. Now I go to K. Here's K over here. Subscript 3, which tells me I have 3. And then PO4. Remember, we put these imaginary parentheses around it. So that means I only have 1. If you have to write in the imaginary parenthesis, that means you only have 1 of them. Okay, if that's helpful. Now I start with the products. Ca, here's Ca. I have 3 of them. So I'll put a 3 there. Then I have PO4 in a parenthesis with a 2 on the outside. So PO4 would be 2. Okay, then I have K, no subscript. Here's K. So that means I have 1. And NO3, no parentheses around it. So how many do we have? Hopefully you recognize that it's only 1, but let's draw our imaginary parentheses around it. So NO3 would be 1. Okay, so we have a lot of work to do here. So we could start with Ca. Here I have 1. Here I have 3. So I want to make this one 3. So I'm going to go back up here. Subscript is 1. So what times 1 is 3? And that would be a 3. So I would put a 3 on that line. So 3 times 1 gives me 3. So my calcium are balanced. But by putting that 3 there, now it changes my NO3s. Without that 3, I have 2 of them because that 2 is on the outside. Once I put that 3 there, now it's 3 times 2, which gives me 6. I'm not going inside the parenthesis, I'm staying outside. So now I have 6 NO3. On this side, I only have 1. Right? Remember, here's my NO3 here. We put the imaginary parenthesis around it. So we know that we have 1, so what times 1 would give me 6, and that would be a 6. So my coefficient here would be 6. So that's going to change my NO3s here to 6, but look what else it changes. It changes my K. K has no subscript, so that means it's 1, so 6 times 1 is 6, so that also gives me 6K, okay? Now, the K over here, there's only 3. How can I make that 6? Let's go up to the part K3. So what times 3 is going to give me 6? And that would be a 2. So 2 times 3 gives me 6. So this changes to a 6. So now I've got 6. That's good. But by putting that 2 there, okay, remember we put the PO4 in an imaginary parenthesis, which meant we had 1. So 2 times 1 gives me 2. And I have 2. So I've got 3, 6, 6, 2. Balanced. Very good. Now I just want to show you one other thing, and then I'm going to give you a couple equations to try just to see, if you understand. You can email me questions if you want to, if you're not sure of something, okay? If I had, we were talking about, let's look at SO4. So let's say I have in a formula, let's say I have CaSO4, okay? If I had 4 SO4s in the formula, then I would see a parenthesis around it and a 4 on the outside. So just remember that this number on the outside is going to tell me how many, okay? And the 4 on the inside, this 4 here, is part of the formula. Okay, so if I looked up SO4 or sulfate, it's called sulfate, I would see that that 4, that O4 is part of the formula. Okay? All right, I hope that helped. And keep doing your work. You're doing great. I'm trying to look at everything. Okay? So let's see what we can do with these, with our polyatomic ions. And, we'll go from there. Okay? All right, have a good day. Bye.